Okay, so in this video we're actually going to focus on two sets of conversions. I'm going to do it all in one video. This is on the top of page 3 and then on the top of page 4. So the first thing we're going to focus on is converting from polar coordinates, which would be r theta, okay, to rectangular, which is xy, which is what we're used to. Okay, and what we need to look at is the relationship of x, y, r, and theta. So I can actually put all 4 of these on this coordinate plane here. So I'm going to draw a right triangle, okay, and I will label here. So this is my x, this is my y, this is my r, and this is my theta. So I have all of the relationships on here in quadrant 1. So if we are trying to get to x and y given r and theta, we're given r and theta in relation to theta, I can actually use my trig relationships here, knowing for x, if we're trying to solve for x, that the cosine of theta is equal to adjacent over hypotenuse, which is going to be x over r. So in this case, because we want to solve for x, okay, I'm going to multiply by r. So to find x, that is going to be r times the cosine of theta. Okay, so let's highlight this. This is one thing that we need to commit to memory. Okay, so then in the same thought process with respect to our trig, if we're trying to find y and we're given r and theta, we can actually use the relationship of the sine of theta is equal to opposite over hypotenuse, and then we would proceed to solve for y in this case. So when we solve for y, it's r times the sine of theta, and this is what we need to remember. So in our examples, what we will be given is a polar coordinate, okay, which is going to be r theta, all right, and we will find the corresponding rectangular coordinate, which will be in the form of xy. So now what we want to look at is, what if we want to go from rectangular to polar? Okay, so this is on the top of page 4. Okay, we want to convert from rectangular, which is xy, to polar, which will be r theta. Now this process is a little bit longer, okay, and I'll do the same thing. I will draw my reference triangle, okay, in quadrant 1. So this is x, this is y, this is r, and this is theta. So remember, you're given x and y. So what we want to look at here is, what is the relationship that I have? And unfortunately, because I don't know what theta is, I can't use sine and cosine. So what I can use is what I'm given. If I'm given x and y, I can use a relationship of the tangent. So what we have here is the tangent of theta, and we're going to call this prime, because this isn't necessarily going to be our the angle that we're looking for. It just depends on the location, is equal to y over x, and we're actually going to take the absolute value of that. So if we turn around and solve for theta prime will be equal to the inverse tangent of the absolute value of y over x. Okay, so we need to know this. And I'm going to go through all the steps here so that we know where we're going with this. And then we'll come back to r in just a minute. Okay, so the steps to find theta. What we want to do is find the reference angle, theta prime, by using this formula that we just found here. Okay, and once we do that, we need to determine which quadrant theta lies in. And the way we do that is we look at xy from the original problem. So we need to determine, if this is our coordinate plane here, if we have positive, positive, we're in the first quadrant. If we have negative, positive, we're in the second. Negative, negative is in the third. and positive, negative will be in our fourth. So you just need to look at where this point is. Then, once we do that, we will come here, and we've actually seen this before. Okay, this is for reference angles, if you guys recall. If theta prime is in the first quadrant, then the angle that we're looking for will actually just be theta prime. Okay, because it'll be somewhere in here. Okay? If theta prime is in the second quadrant, okay, what we have here is this right here is theta prime. But what we want is this angle from here to here. Okay, so the way we find what that angle is, if you recall, it's pi minus theta prime. So you have to know where this point is so that you know which method to use, and the way we do that is by this here in step number 2. So again, if our theta prime, which is right here, okay, is in the third quadrant, then this will be pi plus theta prime, because remember, we're looking for this whole thing. So if this is theta prime, to get from here all the way to here, we're going to take, this is 180, which is pi, and just add on that theta prime, and then the last would be 2 pi minus theta prime. Okay, so this all comes from what we've done before. So what you need to understand is that if we are given our rectangular coordinates, which is x, y, okay, and we want to find our polar coordinates, which is r theta, you need to make sure you clearly read the directions, because typically you will be asked for a primary representation. Okay, and what that means is that r will be positive and your angle will be between 0 and 2 pi. The last piece here, and you just need to understand this, if the ratio for your trig for the tangent is common, you do not use a calculator. If the ratio is uncommon, meaning it's not something that we can get from the unit circle, we will use a calculator. Okay?